European Service Module, ESM. The European Service Module, ESM, is the service module, also known as an equipment module or instrument compartment, component of the Orion spacecraft, serving as its primary power and propulsion component until it is discarded at the end of each mission. In January 2013, the National Aeronautics and Space Administration, NASA, announced that the European Space Agency, ESA, will contribute the service module for Artemis 1 mission, based on the ESA's Automated Transfer Vehicle, originally Ariane Transfer Vehicle or ATV. It was delivered by Airbus Defence and Space in Bremen, in northern Germany to NASA at the end of 2018. After approval of the first module, the ESA will provide the ESMs from Artemis 2 to Artemis 6 missions. The module's first flight was Artemis 1 mission, the first major milestone in NASA's Artemis program to return humans to the Moon, on November 16, 2022. The Space Launch System, SLS, launched Orion spacecraft toward the Moon, where the ESM placed the spacecraft into distant retrograde orbit, DARO, around the Moon, and subsequently extracted it from that orbit and sent it back to Earth. The service module, SM, supports the crew module, CM, from launch through to separation prior to re-entry. It provides in-space propulsion capability for orbital transfer, attitude control, and high-altitude ascent aborts. It provides the water and oxygen needed for a habitable environment, generates and stores electrical power, and maintains the temperature of the vehicle's systems and components. This module can also transport unpressurized cargo and scientific payloads. Roughly cylindrical in shape, the original American-designed Orion service module, like the crew module, would have been constructed of aluminium-lithium alloys, ALLI alloys, to keep weight down, and would have featured a pair of deployable decagonal solar panels, also known as solar cell panels, or solar electric panels, similar in design to the panels used on the Mars Phoenix lander. The panels, the first to be used on a United States crewed spacecraft, except for a 10-year period, the Soviet-Russian Soyuz, Russian, Soyuz, literal translation, Union, spacecraft has used them since the first mission in 1967, would allow NASA to eliminate the need to carry malfunction-prone fuel cells, and their associated hardware, mainly liquid hydrogen, H2, tanks, in the service module, resulting in a shorter and more maneuverable spacecraft. Successful initial testing of an Orion solar array design using full-scale, ultraflex wing, hardware was reported in October 2008. The Orion main engine, OME, was a 33 kN, 7,500 pound force, thrust, pressure-fed, regeneratively cooled, storable bipropellant rocket engine to be made by Aerojet. The OME was an increased performance version of the 27 kN, 6,000 pound force, thrust rocket engine used by the Space Shuttle for its orbital maneuvering system. The Service Module Reaction Control System, RCS, the spacecraft's maneuvering thrusters, originally based on the Apollo Quad system, but resembling that used on its predecessor, Gemini, would also be pressure-fed, and would use the same propellants. NASA believed the Service Module RCS would be able to act as a backup for a trans-Earth injection, TEI, burn in case the main service module engine failed. A pair of liquid oxygen tanks, similar to those used in the Apollo Command and Service Module, CSM, would provide, along with small tanks of nitrogen, the crew with breathing air at sea level or cruising altitude, pressure, 1 or 0.7 atm, with a small surge tank, providing necessary life support during re-entry and touchdown. Lithium hydroxide, LiOH, cartridges would recycle the spacecraft's environmental system by scrubbing the carbon dioxide, CO2, exhaled by the astronauts from ship's air and adding fresh oxygen and nitrogen, which was then cycled back out into the system loop. Because of the switch from fuel cells to solar panels, the service module would have an onboard water tank to provide drinking water for the crew, and, when mixed with glycol, cooling water for the spacecraft's electronics. Unlike the practice during Apollo of dumping both water and urine overboard during the flight, the Orion would have an onboard recycling system, identical to that used on the International Space Station, ISS, to convert both wastewater and urine into both drinking and cooling water. The service module also mounted the spacecraft's waste heat management system, its radiators, and the aforementioned solar panels. These panels, along with backup batteries located in the Orion crew module, would provide in-flight power to the ship's systems. The voltage, 28 volts direct current, DC, was similar to that used on the Apollo spacecraft during flight. The Orion service module would be encapsulated by fiberglass shrouds jettisoned at the same time as the Launch Escape System, LES, Boost Protective Cover, BPC, which would take place roughly 21/2 minutes after launch, 30 seconds after the solid rocket first stage was jettisoned. Prior to the Orion 606 redesign, the Orion service module resembled a squat, enlarged version of the Apollo service module. The Orion 606 service module design retained the 5-meter, 16-foot width for the attachments of the Orion service module with the Orion crew module, but used a Soyuz-like service module design to allow Lockheed Martin to make the vehicle lighter in weight and permitting the attachment of the decagonal solar panels at the module's midpoints, instead of at the base near the spacecraft rocket adapter, which might have subjected the panels to damage. The Orion service module was projected comprising a cylindrical shape, having a diameter of 5 meters, 16 feet, and an overall length, including thruster, of 4.78 meters, 15 feet 8 inches. The projected empty mass was 3,600 kilograms, 8,000 pounds, fuel capacity was 8,200 kilograms, 18,000 pounds. A review of the Constellation program in 2009 by the Review of United States Human Spaceflight Plans Committee, better known as the HSF Committee, Augustine Commission, or Augustine Committee, prompted by the then new Obama administration had found that 5 years in, the service module development program was already running 4 years behind its 2020 lunar target and was woefully underfunded. The only element worth continuing was the crew exploration vehicle in the role of a space station escape capsule. This led in 2010 to the administration canceling the program by withdrawing funding in the proposed 2011 budget. A public outcry led to the program being frozen rather than outright cancelled, and a review launched into how costs could be cut, which found that it was possible to continue if there was an emphasis on finding alternate funding, reducing the complexity by narrowing the scope to focus on the Moon and deep space rather than Mars, and by reusing existing hardware, reducing the range of equipment requiring development. The Ares 1 orbital launch vehicle intended for crew flights had significant design issues such as being overweight and prone to dangerous vibration, and in the case of a catastrophic failure its blast radius exceeded the escape system's ejection range. Its role as the Orion launch vehicle was replaced by the Space Launch System, and the 3 different Crew Exploration Vehicle, CEV, designs were merged into a single multipurpose crew vehicle, MPCV. In May 2011, the European Space Agency's Director General announced a possible collaboration with NASA to work on a successor to ESA's automated transfer vehicle. ESA's provision of this successor could be counted towards its 8% share of the operating costs of the International Space Station. The ATV missions resupplying the station only covered this obligation up to 2017. On June 21, 2012, Astrium announced that it had been awarded 2 separate studies to evaluate possible future missions building on the technology and experience gained from its development of ATV and the Columbus Laboratory. The first study looked into the construction of a service module which would be used in tandem with the Orion capsule. The second examined the production of a versatile multipurpose orbital vehicle. Each study was worth €6.5 million. In November 2012, ESA obtained the commitment of its member states for it to construct an ATV-derived service module for Orion, to fly on the maiden flight of the Space Launch System, thereby meeting ESA's budgetary obligation to NASA regarding the ISS for 2017 to 2020. No decision was made about supplying the module for later Orion flights. In January 2013, NASA announced its agreement, made the preceding December, that ESA would build the service module for Exploration Mission 1, EM1, renamed Artemis 1 mission, then scheduled to take place in 2017. This service module was not required for Exploration Flight Test 1, EFT1, previously known as Orion Flight Test 1, OFT1, in 2014, as this used a test service module supplied by Lockheed Martin. On November 17, 2014 ESA signed a €390 million fixed-price contract with Airbus Defence and Space for the development and construction of the first ATV-based service module. In December 2016, ESA's member states agreed it would extend its commitment to the ISS to 2024, and would supply a second service module, as part of the resulting budgetary obligation. The service module is approximately 5.0 meters, 16.5 feet, in diameter and 4.0 meters, 13 feet, in length, and made of aluminium-lithium alloy. For the first 6 service modules, the main engine will be a refurbished AJ-10-190 previously used with the Space Shuttle Orbital Maneuvering System, OMS. For example, the engine used on Artemis 1 mission had previously flown on 19 Space Shuttle missions, performing a total of 89 burns. The engine provides 26.6 kilonewtons, 6,000 pounds force, of thrust. The AJ-10 design itself has a long heritage, dating back to 1957 when it was developed for the Vanguard rocket, one of America's earliest launch vehicles. A variant of the AJ-10 was also used on the Apollo service module. For future missions, Aerojet Rocketdyne will deliver up to 20 new Orion main engines, OME, based on the AJ-10 design. In comparison with the Apollo Command and Service Module, which previously took astronauts to the Moon, the European Service Module generates approximately twice as much electricity, 11.2 kilowatts versus 6.3 kilowatts, weighs nearly 40% less when fully fueled, 15,461 kilograms 34,085.67 pounds, versus 24,520 kilograms 54,057.35 pounds, and is roughly the same size, 4 meters, 13 feet, in length excluding engine and 4.1 meters, 13 feet 5 inches, versus 3.9 meters, 12.8 feet, in diameter, supporting the environment for a slightly, 45%, larger habitable volume on the crew module, 8.95 cubic meters, 316 cubic feet, versus 6.17 cubic meters, 218 cubic feet, though it will carry 50% less propellant for orbital maneuvers, 8,600 kilograms, 18,959.75 pounds, usable propellant versus 18,584 kilograms, 40,970.71 pounds. The ESM will be able to support a crew of 4 for 21 days, which exceeds the 14-day endurance for the 3-man Apollo. The new design for the solar arrays, replacing Alliant Tech Systems Incorporated's, ATK's, decagonal, labeled, circular, Ultraflex design, is by Airbus Defence and Space, whose subsidiary, Airbus Netherlands, then known as Dutch Space, built the ATV's X-shaped array of 4 panels. The ATV's array was expected to generate 4.6 kilowatts. The upgraded version for the service module will generate about 11 kilowatts, and will span about 19 meters, 62 feet, when extended. In September 2015, Thales Alenia Space signed a contract with Airbus Defence and Space to develop and produce thermomechanical systems for the service module, including structure and micrometeoroid protection, thermal control and consumable storage and distribution. Lockheed Martin is building the 2 adapters, connecting the service module to the crew module and to the upper stage of the Space Launch System, and also the 3 fairing panels that are jettisoned after protecting the service module during launch and ascent. On February 16, 2017, a €200 million contract was signed between Airbus and the European Space Agency for the production of a second European service module for use on the first crewed Orion flight. On October 26, 2018, the first unit for Artemis 1 was assembled in full at Airbus Defence and Space's factory in Bremen. In November 2019, ESA member states approved the financing of ESMs for Artemis 3 and 4. In May 2020, the contract between Airbus and the European Space Agency for the production of a third European service module was signed. In October 2020, ESA and NASA sign a Memorandum of Understanding, MOU, which includes the provision by ESA of ESM-4 and ESM-5 as a participation in the Gateway space station, allowing 3 flights of European astronauts to lunar orbit between 2025 and 2030. In February 2021, the contract between Airbus and the European Space Agency to provide ESM-4 to ESM-6 was signed.